Good
Good
evening,
evening.
beta. Good evening, beta. So in the last class, I was discussing Young's double slit experiment. So you are having a source, ठीक है ना, which is emitting spherical wave fronts like this. And if you place, this is a symmetrical axis, and with respect to the source, we have placed two slits symmetrically. ठीक है ना, we have placed two slits symmetrically like this. Now wavefronts emerging from the source, this source, they are striking this slit plane, and what is happening? A part of the wavefront is emerging from this slit one, and another part of the wavefront is emerging from slit two. So what is going to happen? This slit one is going to act as a source, independent source, and this S2, it is acting as another independent source, because these two sources, they are obtained from the same source. So whatever light is emerging from these two sources, frequency and wavelength of that light will be same, because medium is not changed. Here medium was air, here medium is air, so wavelength will also remain same. So frequency is same, wavelength is same. Second, we have placed this S1 and S2 symmetrically with respect to this S. So this distance, this this part difference, S1 S, this path traveled by this wave part of the wavefront, it is exactly equal to the path traveled by the another part of the wavefront before reaching S2. They are equal. So what is the path difference between these two? That is 0. So you can say S1S, S1S minus S2S, S2S. That is path difference, that is 0. That is 0. So what will be the phase difference? Phase difference delta in between these two light sources. ठीक है ना? That will be 2 pi by lambda into part difference, and that will also be 0. So when these light waves are emerging from S1 and S2, at that time phase difference between these light waves or these wave fronts is actually 0. It is 0. Now what we have done, we have placed a screen here. We have placed a screen here. This is the central point of the screen. Now light from S1 and S2. Try to understand, light from S1 or wavefront from S1 is reaching at this point P, and wavefront emerging from this S2, it is also reaching at P. It is also reaching at P. Now what is the intensity here? In the last class we find out intensity I at point P, it will be E10 square plus E20 square plus 2 times E10, sorry, or I can write it as E20 square plus 2 times E10, E20, and cos delta. Now what is the delta here? ठीक है, this was the phase difference between these two. If you calculate this delta here, so I'm removing this part. So what is the delta when this part of the wavefront is reaching at P, this part of from S2 wavefront is reaching at that point P, and they are overlapping. So before reaching at P, they have traveled distances S1P and S2P respectively. So they have traveled different paths. So there will be a part difference between them. And what is that part difference? Part difference is equal to S2P minus S1P. So they have traveled different paths. So there is a part difference between them, and that part difference will be corresponding to a phase difference. So phase difference here, that will be delta. So delta is the phase difference when light waves from S1 and S2, they are reaching at P. So that phase difference is here. And what is E10 and E20? That is the amplitude here. This is E10 is the amplitude of the light waves emerging from S1, and E20 is the amplitude of the light waves which are emerging from S2. So they are amplitudes respectively. Now, this is the expression of intensity at any arbitrary point on the screen. So you can find out the intensity at any arbitrary point if you know the phase difference at that point. Any point you can choose and you can find out the intensity with the help of this formula. But only one thing you have to do, you have to find out the phase difference at that point. So how you are going to get phase difference, I will calculate it. Okay? But before that, now look at this formula. Look at this formula. Can you tell me when this intensity will become maximum? Intensity will become maximum when this cos delta will be maximum. Because this E10 and E20, they are constants. E10 and E20, they are constants. They are constants. ठीक है ना? So if they are constants, so cos delta is the only variable here. So when you will move on the screen, automatically this part difference is going to change. As a result, delta is going to change, so cos delta will vary. Cos delta is going to vary. So you are going to get intensity maxima. You will get intensity maxima when cos delta is equal to plus 1. Cos delta is equal to plus 1. And corresponding to this, delta will be how much? This will be 2n pi. This will be 2n pi. So cos 0 is plus 1, cos 2 pi is plus 1, cos 4 pi, 6 pi. Correspondingly, you are going to get plus 1 value for the cos. So delta will be 2n pi. So one formula is this. For this is one of the condition for interference maximas. So you have to remember this. Second, you have to find out the corresponding part difference. Part difference, ठीक है ना, delta you want to find out. So 2 pi by delta, 2 pi by lambda into delta, that is equal to phase difference. That is equal to phase difference. Substitute this value here. So this will be 2n pi and this will be 2 pi by lambda and that will be delta. So 2 pi will cancel out and delta, ठीक है ना, another condition. From here you will find out that delta is equal to n lambda. So you are going to get an interference maxima if part difference is n lambda or phase difference is 2n pi. And what is the value of n? N is equal to, it may be 0, it may be 1, it may be 2, and it will be a positive integer here. Okay? So any positive integer, 0, 1, 2, 3, you can have any value. So correspondingly, look here at this point, because S1 and S2, they are symmetrically placed with respect to O. Here here part difference will be 0. Okay? You are going to get a maxima here. Part difference here is n equal to 0, so this will be 0. And when you will move in the upward direction or downward direction, whenever you are going to get a part difference of a lambda, you will get a maxima. So try to understand here at this point, you are going to get a maxima. Then here, where part difference is lambda, you will get a maxima. Then at 2 lambda, when part difference is becoming 2 lambda, you will get a maxima. Here, corresponding to 3 lambda, you are going to get a maximum. Okay? So wherever part difference, I'm not saying this distance is lambda. No, I'm saying these are part difference. So whenever part difference is lambda, 2 lambda, 3 lambda, 0, you are going to get the maximas here. Maximas here. So at all those points where part difference is this, you are going to get the maxima. So these are the positions where I will show you and I will plot that you are going to get a maxima here. Correspondingly, you can also find out the phase difference corresponding to n equal to 0. Phase difference will be 0 here. Then n will be 1, so this will be 2 pi here. You are going to have 4 pi, 6 pi. These are the phase difference on the screen where you are going to get the maxima. Okay, you are going to get the maxima there. So this will be. Next important thing is what will be the maximum intensity. Okay, next question is what will be the maximum intensity beta. So maximum intensity I max you are going to get when cos delta is plus 1. If you place cos delta is plus 1, then it will become E10 plus E20 whole square. You are going to get the maximum intensity. This is the formula of maximum intensity. Okay, this is the formula of maximum intensity. Is it clear to everyone? Hello.
Yes,
Yes.
sir.
Good. Next. Now, when you are going to get intensity minima, next is intensity minima. Intensity minima. You are going to get intensity minima when cos delta is equal to -1. Cos delta is -1. It will be at pi. When delta is pi, it will be 3 pi. It will be at 5 pi. It will be at 7 pi. So this will be, delta will be 2n plus 1 pi, where n is equal to 0, 1, 2, like this. So delta will be so much. So if I place this delta, I want to find out the part difference corresponding to this. So this will, part difference is suppose delta, multiply it by 2 pi by lambda, and this will be equal to phase difference. This will be equal to the phase difference. So phase difference will be here 2n plus 1, and that will be pi. And that will be pi. So this will be, so this pi is going to cancel out. Pi is going to cancel out. So what will be the part difference? Part difference delta. This will be 2n plus 1, and this will be lambda by 2. Either you write like this, or you can write in another way, that n plus 1 by 2 and lambda. So these are the conditions of interference minima. ठीक है ना? These are the conditions of interference minima. ठीक है? So if you look on this screen, so interference minimas, where you are getting interference minimas. You are getting for delta whenever phase difference is 2n plus 1 pi, or you can say part difference is, I'm writing in this way, n plus 1 by 2. ठीक है ना? And lambda. So try to understand, at this point, part difference is 0. 0. And when you will start moving, it will become lambda by 2. So here it will be lambda by 2. So this is the part difference where you are going to get a minima. So when you will move in the upward, part difference will start increasing. It will become lambda by 2. So first it is going to become lambda by 2. You will get first order minima. After that, ठीक है ना? So you are here. Initially, you are at maxima. You are here when n is 0. ठीक है? After that, you are going to get lambda by 2. So you are here. You are at the minima. On further moving, you will get part difference lambda. So you are again at the maxima. You further move in the upward, you will get 3 lambda by 2 here. Then 2 at 2 lambda, you are getting maxima. And here you are going to get minima 5 lambda by 2. So in this way, alternatively on both sides, you are going to get maxima and minima. So these are the positions of maxima and minima. So because as you move on the screen, you are going to observe different maximas, different minimas. Here at the central point, this is called as central maxima. This is called as central maxima or zeroth order maxima. This is called as central maxima or zeroth order maxima. Now come here. Okay. Now come here. What will be I minimum? If you place cos delta is equal to 1, then this will be E10 minus E20 and whole square. ठीक है? Either E10 is greater or E20 is greater, it doesn't matter here because square will be there. Because square will be there. So this is the formula for I minimum. This is the formula for I minima beta. Now, so here we find out what are the conditions of interference maxima or intensity maxima. We find out the conditions for interference minimas, intensity minimas, what is maximum intensity, what is minimum intensity. You find out all these things.
Sir,
Next,
here,
yes,
if your amplitude is equal, both
if
amplitude
if
is
amplitude
equal,
is equal,
then
I am coming to that point. If amplitude is equal, then intensity will be exactly a dark fringe. You are going to get dark fringe. Okay, intensity will be 0. So your intensity minima will be a exactly dark fringe. Okay, intensity will become 0 here. I'm coming to that point actually. Now, next question is whatever question was this question was asked. If suppose E naught 1. Okay, before that, before explaining that, please understand this. What was the electric field that was emerging from the first slit? I write it like this. This is E naught 1. This was the amplitude. Yeah, E1 naught, whatever it was. This is E10. This was the amplitude. I'm saying its polarization is in y cap direction. This is E vector. And this was e to the power iota omega t. What will be its complex conjugate? Its complex conjugate will be this one. So this will be y cap. This is E2. So this will be E2 not e to the power iota omega t. So when whatever light is emerging from S1 and S2, ठीक है, their electric field profile are these. ठीक है ना? These are electric field profile. Sorry, here I was taking complex conjugate. I have written for other second one. So this will be E1 star, E2 naught, E1 naught, E1 naught, e to the power minus iota omega t. ठीक है? So I have written the profile of other light that is emerging from S2. But here I am taking the complex conjugate of this. So if I multiply, try to understand if I write like this E1 star dot E1, then this will provide me the intensity of the light that is emerging from slit S1. So what is this I1? I1 is the intensity of the light that is emerging from slit S1. So if you take this dot product here, y dot y cap dot y cap, that will be 1. These exponential part, they're going to cancel out. So you will have E1 square. E1 square. What will be I2? Similarly, you can find out I2 as E2 star dot E2, and that will be E2 naught square. Okay, so these are representing the intensity of the light that is emerging from slit 1 and slit 2. So substitute these expressions in this formula. Intensity is given by E10 square plus E20 square plus 2 times E10, E20 and cos delta. ठीक है? So I can write it as I equal to I1 plus I2 plus 2 times square root of I1 I2 cos delta. So in terms of intensity, I can also write this intensity at point P. This is the resultant intensity at an arbitrary point P. If you write I max, I can write I max like this. This will be root I1. This is E10. This is root I1 plus root of I2 and square of this. This will be I minimum. ठीक है? I minimum will be how much? This will be root I1 minus root of I2, and this will be whole square. So these are another formulas of I max and I min in terms of intensity. So you can also do calculation in terms of intensity. Next question is if E naught 1. Next is if E naught 1 is equal to या E1 naught is equal to E2 naught because they are placed symmetrically. ठीक है? If this condition is there, ठीक है ना? Let us consider this case when this they are equal. They are equal. It means you are saying I1 is equal to I2. ठीक है? I1 is equal to I2 and I am calling it as I naught. And here I am saying these amplitudes are A. ठीक है ना? They are A. So what you are going to get? What you will get here? This I, this is E naught 1 square. So I replace E2 naught by sorry, here, every time. So here replace this E2 naught by E1 naught square plus 2 times E1 naught, E2 naught. So E2 naught is equal to E1 naught. So this will be square and this will be cos delta. This will be cos delta beta. So I will be 2 will be common. E1 naught square that will be common. ठीक है ना? That will be common here and this will be 1 plus cos delta. 1 plus cos delta. So this I will be, what is 1 plus cos delta? This will be 2 cos square delta by 2. 1 plus cos delta will be 2 cos square delta by 2 minus 1. So minus 1 will cancel out. So even I can write 2 times E1 naught square 1 plus 2 cos square delta by 2 minus 1. So minus 1 is going to cancel out here. And what you are going to have, you will have 4 E1 naught square and cos square delta by 2. Delta by 2. So one of the formula will be this. ठीक है? If you are taking their amplitude same, so you can write even 4a square cos square delta by 2. Even you can remember like this. This is the formula of intensity. This is the formula of intensity when amplitude of the light emerging from S1 and S2, they are exactly equal. They are exactly equal. Now this, what is this 4a square? If you look it, then you can write this a plus a, that is 2a, and whole square of this. And this is cos square delta by 2. And this is I. This is I. So what is a plus a? So you are saying amplitude is same. So in this case, what will be I max? In this case, I max will be a plus a whole square. So that will be 4a square. And in this case, what will be I minimum? That will be a minus a. And that will be square. So I minimum will be 0. So this will be a perfectly dark fringe. This will be a minima will be a perfectly dark fringe because intensity is 0. If both the slits are identical, size, ठीक है, in size, shape, this they are identical and they are equally placed with respect to the sources. ठीक है, and I maxima will be 4 square. So this is 4a square, or you can say a1 plus a2 whole square. So this is what? This is I equal to I max and cos square delta by 2. This is, so this is the formula when amplitude of the light emerging from S1 and S2, both the slits, ठीक है, they are of same amplitude. When they are of same amplitude, then you are going to use this formula. Now, next, if you plot intensity as a function of delta, ठीक है, if you plot intensity as a function of delta, suppose you plot this, so what you are going to get here, you will get, this is the source here. It is emitting spherical wavefronts. These wavefronts, they are divided into two parts. A part of the wavefront is emerging from slit S1 and another part is emerging from S2. So these are two slits, S1 and this is S2. From here, this wavefront is emerging. And when these wavefronts, they are propagating in the forward direction, when they expand, they will start overlapping, interference will take place. And we can observe this stationary pattern of the interference here. We will get that interference pattern here on this screen. Here, this is called as screen button. And what type of pattern you are going to get here? So here, I'm going to plot delta phase, and here you are going to have intensity. Maximum intensity is here. I'm saying, suppose this line, this is zero intensity here, and here on this axis you are having maximum intensity. So what I plotted here, this line is representing Imax. Imax. So try to understand, you are going to get this type of fringes. This is n equal to 0 fringe. ठीक है, second maxima is suppose here. ठीक है, so you are going to get a maxima here. It will be like this. In this way, you are going to get different fringes on both sides. Their width, these all the maximas, they are identical. Their widths will be same. Everything will be same. This will be. Now, if I write phases here, this is 0 phase. Here you are going to have 2 pi phase. Here this is 2 pi. This is 4 pi. Okay. Here this will be 6 pi. And so on. This will be 4 pi. This will be 6 pi. So here you can observe that the height of all the interference maximas are same. So important point, one important point to note here is, ठीक है ना, one important point here is that height of all interference maximas will be equal. Will be equal. ठीक है? Height of all the interference maximas will be equal. So this is called as central maxima or zeroth order maxima. On the upper side, you can say this is n equal to plus 1, n equal to plus 2, n equal to plus 3. On the lower side, just to represent that they are on the lower side, otherwise there is no difference. This will be minus 1, minus 2. You can say in this way. Or even you can write plus 1, plus 2, plus 2, 3 in this. So This type of interference pattern is observed on the screen. On the screen, you are going to get this type of interference pattern. So why you are getting a minima here or here? Why you are getting this minima? Because when light is reaching here and light is reaching here, so if you calculate the phase difference between these two, that phase difference is providing cos delta equal to -1. -1. That's why you're getting a minima here. Why you are getting a maxima at any point? Suppose here, here. Why you are getting a maxima here? Because light reaching at this point from these two sources, ठीक है ना? They are corresponding to the phase difference cos delta equal to +1. That's why you are getting maximas and minimas here. You are getting maximas and minimas in this way. So height of all the maximas and minimas will be equal here. Is it clear? ठीक है बेटा?
Yes, sir.
Yes, sir.
Another important thing is in this pattern, ठीक है? Why you are getting these maxima and minimas? You're getting maximas and minimas because part difference, ठीक है ना, is n lambda and part difference is n plus 1 by 2 lambda for maximas and minimas. Maximas and minimas. So up to this point, I was using monochromatic light. Here, I was talking about monochromatic light. Monochromatic light. Here, I was talking about monochromatic light. So if you are having monochromatic light, maxima will be of a particular color. Suppose you are using red light, okay, then automatically these maximas will be of red color, minimas will be dark. You are going to get the pattern. Okay, even this type of pattern you can observe in class 11 or 12 laboratories. You are having a laser. Okay, and if you are having two slits, then this type of pattern can be observed. You can observe this type of pattern. Okay,
Okay.
now another thing is I want to replace this monochromatic light by the white light. So what I'm saying now, I'm saying suppose you replace this source of monochromatic light by white light. Then what is going to happen? Here two slits are there, S2, S1. And here we are having a screen. So actually now what will happen here at this point? What is the condition at this point? That is delta equal to n lambda. And n is 0 here. 0 lambda, so this will be 0. So lambda can be of any color. Try to understand, you can have red light, blue light, green light, yellow light. ठीक है, lambda is not mattering here. So for every color light here, part difference will be 0. So you are going to get a white maxima here. What I'm going to get here, this will be a white color maxima. Central maxima will be white. But for other, try to understand where you are going to get first order maxima when delta is equal to lambda. On this side, you are going to get delta equal to lambda. So these are the conditions. But lambda for different colors is different. ठीक है ना? You are having white light is made up of VIPGO. VIPGO. ठीक है? it is having maximum lambda. Lambda max is for this, and this will be for minima, lambda minimum. So you will find out that maxima, first order maximas of different color, they are not going to coincide. They will fall at different points. ठीक है ना? Similarly here, first order maxima, second order maxima, third order maxima. Now they are maximas of different colors. They will not coincide with each other because lambdas are different. So for one, lambda is different. So you are going to get a maxima for one color here, for second color, third color, fourth, fifth, sixth, seventh. So I will explain you later. Actually, this beta, ठीक है, fringe width, this is equal to, I have not introduced yet, that is d lambda by कितना होता है, small d. This beta is the separation between two maxima. So first order maxima will be at a distance, this beta equal to d lambda by d. So lambda, so color for which lambda is minimum, that will be closest to the central maxima. So here this will be V. And on this side, you are going to get R. Similarly, here it will be made up of 7 color, 1, 2, 3, 4, 5, 6, 7. This will be V, Gur. This will be R, sorry. This will be R. So basically, central white maxima, it will be surrounded by colored maximas. So central white maxima will be surrounded by will be surrounded by colored maximas colored maximas on both sides on both sides. You are going to get this. So if you are doing an experiment YDSC in the laboratory and you want to find out where is my center of the screen, ठीक है, you want to denote where is the center of the screen. If you are suppose using monochromatic light, try to understand what problem you are going to face. Suppose you are going to get monochromatic light, then you are aware that all the maxima n equal to 0, 1, 2, 3, 4, they are of same intensity. And because you are using monochromatic light, color will be same. So you cannot find out which is my central maxima. So by using monochromatic light, it is not possible as to find out, okay, this is the center of the screen and this is the central maxima or zeroth order maximum. So what you do, you will replace for a moment your monochromatic source by the white light, and central maxima, zeroth order maxima, this will be of white color. And wherever you are getting that white color maxima, denote that that is the position of the zeroth order maxima. Then again, white source can be replaced by the monochromatic source, and you can find out the separation and everything, whatever calculation you want to do, you can do. So in this way, this is another aspect of this. ठीक है. One more thing is, what type of fringes are formed here? So next is actually two type of fringes you are going to observe. Fringes. Two type of fringes you are going to observe. ठीक है. One is non-localized fringes. Non-localized fringes. And second are localized. Localized fringes. ठीक है. So in cases where you are creating these these coherent sources by the division of wavefront, For example, in YDSC experiment, in Fresnel biprism experiment, in Lloyd's mirror experiment, you are going to get non-localized fringes. Non-localized fringes, ठीक है ना? They are not they are not constrained. They are not lying within some plane. They are not localized within a plane, but they are going to fill the complete space in front of the slits. So what I'm saying, the meaning is here. Try to understand from here. This these coherent lights are emerging. These wavefronts are emerging. They are going to overlap over each other. They will overlap. So basically, this complete space in front of S1 and S2, that will be filled by the maxima and minima. You can place your screen anywhere. You can place your screen here. You can place your screen here. You can place your screen here. You will get a pattern on the screen. So it's not necessary that, okay, we are going to place screen at a particular place, only then we are going to get the pattern. No, this complete space is filled by the maximas and minimas. So these maximas, these minimas, these fringes, they are not localized to any plane. You can place your screen anywhere in front of these slits, you are going to get the pattern. So here, fringes are not localized to a plane. So what I'm saying here, these fringes are not localized, are not localized in any particular plane, in any particular plane, rather they will fill these fringes, these fringes fill the complete space, fill the complete space in front of slits. S1 and S2. So examples here are YDSC, Fresnel biprism experiment, Lloyd's mirror, ठीक है ना? So these are the examples where you are going to observe non-localized fringes. While localized fringes, they are confined in a particular plane. These fringes are confined in a particular plane. If you observe that, they are observed in those cases where you are getting coherent sources by the division of amplitude. ठीक है? In a particular plane, like Newton's ring experiment, Michelson interferometer, thin film interference. ठीक है? In these cases, you are going to get localized fringes. So here in YDSC experiment, you are getting non-localized fringes. You are getting non-localized fringes, but in case of this. Now, now discuss some of the questions, ठीक है ना, based on whatever we have discussed so far. ठीक है? So first question is, the two slits in a YDSC are of unequal width. ठीक है? There are two slits, their widths are different. So try to understand, one being 4 times wider than the other. Try to understand one width. Width of one slit is like this. Suppose this is slit S1. This is slit S1 and here I call it as S1. And the second slit, it is wider, 4 times wider like this. This is S2. So what will happen due to this? It means I2 is 4 times I1. Okay? So what will be the intensity here? Whatever light is emerging, its intensity will be 4 times as compared to the intensity that is emerging from S1. So if I assume I1, if I'm saying I1 is suppose A square, then what will be I2? I2 will be 4 times I1, or I can write it as 4A square, or I can write this is 2A square. So what is the amplitude here? What is A1? I can write A1 is equal to A. And what is A2? That is 2A here. So if width is made 4 times, means intensity of light emerging from the wider slit, it will be 4 times. Intensity becomes 4 times. So if this is A square assuming, then this will be 4A square. So this will be 2A square. So in this way, you can write I1 and I2. So what will be I minimum here? I minimum divided by I max. I min will be A2 because A2 is greater. I'm writing A2 minus A1 whole square divided by A2 plus A1 whole square. So this will be 2A minus A whole square, and this will be 2A plus A whole square. So this will be A square here is it will be 2 plus 1 3 square. So this will be 9A square. So this will be 1 upon 9. So what will be the answer here? Answer will be 1 upon 9. So here answer will be equal to 1 upon 9. Is it clear to everyone, beta?
Yes, sir.
Yes,
Yes,
sir.
sir.
Good.
सर
Next question. हाँ जी बेटा
सर
please. Yes please.
एक डाउट है ये इंटेंसिटी विड्थ के साथ कैसे है
Proportional to width. Intensity is proportional to the width. ठीक है ना? Intensity is proportional to the width. This is a very good approximation here in case of slits.
Sir,
Next. Yes, beta, please.
in the previous slide, I have a doubt.
Yes, beta, please.
Why A1 is A and A2 is equal to 2A, sir?
No, actually they are providing me the width. This is 4 times. So from here, I have approximated that I2. It is nearly 4 times I1. ठीक है? It is 4 times I1. So I am assuming. So here I can write let. Let I1 is equal to A square. So what is I2? I2 is 4 times I1. So this is 4 times I1. So this is 4A square. How can you write 4A square? Intensity is amplitude square. So that's why I write 2A square. So intensity is amplitude square. So A2 will be equal to 2A. Okay? Because intensity is amplitude square. That's why I'm saying this 2A is the amplitude of the light emerging from S2. So that's why A1 is A. I have assumed correspondingly A2 is coming out to be 2A. So in this way, you can solve this question in a very simpler manner. Now go to the next question, question number 2. Interference fringes are seen at an observational plane Z equal to 0. So Z is becoming 0 by the superposition of two plane waves A1 e to the power this and A2 e to the power this, where A1 and A2 are real amplitude. The condition of interference maxima is this. They are asking us to write the condition of interference maxima. So what is the condition of interference maxima? Interference maxima. What is the condition for this? There are two conditions, delta phase difference that should be 2n pi. Path difference is equal to n lambda. ठीक है? I cannot find out path difference here, but phase difference I can find out. What is the phase of first wave? This term k1z minus omega t. Argument of this exponential. ठीक है? With this I, that is called as phase. Argument of sine term or argument of this exponential term that is in multiplication with iota, that is called as the phase. So here, phase for the first wave, phi1, you can write that is k1 dot r, k1 dot r minus omega t, minus omega t. This is the phase for the first wave. For the second wave, this is the phase. So for the second, this is phi 2. This will be k2 dot r minus omega t. So what is the phase difference delta? Delta will be phi 1 minus phi 2 or phi 2 minus phi 1. Phi 1 minus phi 2. So this will be omega t will cancel out and this will become k1 minus k2 dot r and this is delta. And for interference maxima, this should be equal to 2n pi. So this will be the condition of the maxima. For interference maxima, this will be the condition. So which is this one? This option B beta. So option B is the correct answer. So here option B is the correct answer. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Next question. In an interference pattern formed by two coherent sources, the maximum and minimum intensities are 9 I0 and I0 respectively. ठीक है, 9 I0 and I0 respectively. The intensities of individual waves is, so I'm assuming individual wave intensities are A1 square, and for second one, this is A2 square. A2 square. So what they are saying, intensity maxima. ठीक है, maximum and minimum intensity. So what will be I max divided by I min? I max will be how much? I max is given by A1 plus A2 whole square, and I min, this is given by A1 minus A2 whole square. How much is I max? I max is 9 I0 and I min is I0. So I write here 9 I0 divided by I0. So I0 will cancel out. This will be 9 only. So take the square root of this equation. This will be A1 plus A2 divided by A1 minus A2. You can do one more thing, but later on I just want to explain this. This will be 3. This will be 3. So this will be 3 times A1 minus 3 times A2. This will be A1 plus A2. So this will be 2A1 on this side, and this will be 4 of A2. So 2A2 is equal to A1. A1. ठीक है? So if you make the square of this, ठीक है? तो इनमें से what will be the correlation? You can say, suppose this is I0, then what is A2? A2 is A1 by 2. A1 by 2. A1 by 2 square. So I write in this way. Just make it more simpler. ठीक है? Because A2 is lesser. A2 is lesser, so I am taking it as I0. ठीक है ना? I0. A1 is 2A0. So I write it as 2A2 square, 2A2 square. And so this will be 4 times A2 square. So this will be 4 of I naught. So this will be 4 I naught and I naught. So this will be 4 I naught and I naught. So I have used in this way because try to understand this is lesser. ठीक है ना, A2 is lesser, so I assume this A2 is square intensity I2 as I naught. ठीक है, and then larger amplitude I have written A1 in terms of A2, so this will be 2A2 square. 2A2 square, 4A2 square, so intensity will be 4 I naught. So answer is 4 I naught and I naught. 4 I naught and I naught. This will be the answer, beta. Is it clear?
Yes, sir.
Good. Now go to the next question, beta. The condition for maxima in the interference of two waves. This wave is given, this wave is given. What is the condition of maxima? So again write this one. This is the phase of the first wave. Okay, so phi 1, I'm writing phi 1. Phi 1 is how much? K naught. This will be K naught by 2 root 3x plus y minus omega t. Phi 1 for second wave phase is equal to K naught by root 2, and this will be x plus y minus omega t. So find out phase here. This is lambda or pi? Okay. So you have to find out in terms of lambda here. Okay. So these are the phases. And what is this condition telling you? What is this condition? Condition is corresponding to part difference. But I know the phase difference. So first I find out phase difference. Delta phi. Delta phi or delta? I write it as delta or delta phi, whatever you want to write. ठीक है ना, here I was using this as delta. So delta is equal to phi 1 minus phi 2. Phi 1 minus phi 2. So it will be, look here, this will be k naught. ठीक है ना, this will cancel out by this. K naught will be common. ठीक है ना, k naught is common. So this will be root 3 by 2. Root 3 by 2. And this will be minus 1 by root 2. And this will be x. Second, this will be plus 1 by 2. 1 by 2 y is here. This will be minus 1 by root 2 into y. This will be. Okay. So what you do here, multiply here by root 2 and root 2. So in denominator you will have 2. Similarly, multiply here by root 2 and root 2. So this will be 2. And take that 2 common. So this will be k naught by 2. And what you are going to have in the bracket, this will be root 3 minus this will be root 2. And from where I have taken this hint? From the options. Plus this will be 1 minus root 2, and that will be y. This is what? This is phase difference. This is phase difference. And if I want to find out part difference delta, that will be 2 pi by lambda. That will be 2 pi by lambda into delta. ठीक है ना? So, sorry, उल्टा लिख दिया मैंने. Please correct it. Phase difference will be equal to, कितना होगा बेटा? Phase difference is equal to 2 pi by lambda into part difference. So part difference will be lambda upon 2 pi into delta. And what is 2 pi by lambda? 2 pi by lambda कितना होता है? 2 pi by lambda is defined as propagation constant. Here propagation constant is k naught. K naught. So I can write it as delta by K naught. This will be delta by K naught. And this is delta. So substitute this. So this K naught, when you will substitute delta here, so K naught will cancel out. And this will be 1 by 2. In bracket, it will be root 3 minus root 2 x plus 1 minus root 2. This will be y and it is equal. And what will be the condition of maxima? What do you want? You want maxima. What will be the condition of maxima? Condition of maxima will be that this part difference, it should be equal to n lambda. N lambda for maxima. For interference maxima, it should be equal to n lambda. So bring this 2 on this side. If I bring this 2 on this side, this will be 2n lambda. And on the right side, I will have root 3 minus root 2 into x plus 1 minus root 2 y. This will be. Okay, so my answer will be, which one is our answer? First one, na? This will be option A. Option A will be our answer. Option A is our answer. Is it okay?
Yes, sir.
Yes, sir. Next question, beta. Look at this. Now here 4 options are given. So electric fields of 2 light sources with nearby frequencies omega 1 and omega 2 and wave vectors, this k1 and k2 are expressed as this. ठीक है ना? So this is expression for E1. And here another expression is for E2. So here now you can see these two waves separately, respectively. The interference pattern on the screen is photographed at t equal to t naught. So what they are saying that phase difference, what you are going to look here, phase difference at t equal to t naught. And they are saying that this quantity k1 minus k2z minus omega 1 minus omega 2 t naught, this is denoted by theta. ठीक है ना? They are saying this is theta. So what they are saying me, okay, this k1 minus k2 into z minus this is omega 1 minus omega 2 into t naught. They are saying this is theta. ठीक है? Now, they're talking about bright fringe will be denoted by cos theta equal to -1. So can you tell me when you are going to have a bright fringe? What will be the condition of bright fringe? What is the phase difference here? So phi 1 for the first wave, phi 1 is k1z minus omega 1t. What is phi 2? Phi 2 for the second wave is this k2z minus omega 2t. So these are the phases. Phase difference delta, that will be k1 minus k2 into z. That will be phi 1 minus phi 2. And here this will be minus omega 1 minus omega 2. And this will be t. Now they are talking about at time t equal to t naught. So at time t equal to t naught, this will be the phase difference. So what is this? This is the phase difference. And they are denoting this as theta. What they are saying? They are denoting this phase difference delta by theta. So for the bright fringe, what is the condition in terms of this delta? That should be cos delta, phase difference. कितना होना चाहिए for bright fringe? That should be +1. ठीक है, but delta is theta, so my conditions for the bright fringe should be cos theta should be +1. So for bright fringe, cos theta should be +1. If you look at dark fringe, what is the condition for minima or dark fringe? This cos delta should be -1. So here in our case, this will become cos theta. We are talking at time t equal to here. Try to understand frequencies are not same. So continuously phase is changing. So they have stopped the phase at time t naught. So they are asking me, okay, at time t naught, tell me the condition of maximas, minimas, bright fringe, dark fringe. They are saying this. So why they are using this t naught time? Because phases, they are not constant. Phase difference between them is not constant. So that's why they are talking about a particular time. Okay, at this time, what is the condition of maxima? What is the condition of minima? So cos theta, that should be -1. This is one of the question they are asking. Second question is bright fringe intensity is given by. Bright fringe intensity will be Imax. And how much it will be? Amplitude here is E10, here amplitude is E20. So I maximum, this will be E10 plus E20 whole square. This will be the intensity of bright fringes. For the dark fringes, if you write, this will be I min and it will be E10 minus E20 whole square. So these four statements, look at now state. The bright fringe will be denoted for cos theta equal to -1. No, that is a wrong statement. A bright fringe intensity is given by E10 square plus E20 square. This is wrong. A dark fringe will be denoted by cos theta equal to +1. No, for dark fringe cos theta will be -1. Now fourth is here. A dark fringe intensity will be E10 minus E20 square. So this is correct. This is correct. So option D is the answer here. So correct option is option D. So option D is the correct answer here.
Sir,
ठीक, yes beta please.
sir, here since K1, K2 are different, omega 1, omega 2 are different, like how is the cos theta formula still valid, sir? Because if we take
No.
E1, E2
Theta,
star,
no. Yes, your question is correct. What is the question is actually, student is saying that phase difference is not constant. ठीक है? Phase difference is not constant. So surely what you are saying, you are correct. We are not going to get a stationary pattern on the screen. If I observe the pattern here, that pattern will continuously change. At one point, at one time, at a particular position, you are getting maxima. After some time, you will get a minima. So that's why he photographed this pattern. Pattern is continuously changing. So he photographed this pattern at t equal to t naught. So at t equal to t naught, ठीक है, because pattern is taken. So at some points you will have maximas, at other points you will have minima. So he's talking about that at this particular time, what will be the condition of the maximas, which we have photographed. What is will be the condition of minimas. So this formula is applicable. ठीक है ना, this formula is applicable for the stationary pattern, that is okay. But when you have photographed it, you have stopped the time. What you have done, you have stopped the time by taking photograph. So at that particular time, this formula will be valid. ठीक है ना, this formula, yes beta please.
sir, if we do this by like taking E1 and E2 star, multiplying E1, E2 star, then
Yes,
E power.
but you have to take, you in that case you have to take t not constant.
Yes, sir. Even taking T naught constant, in that case, we are getting e power plus I K2 Z minus omega t. But there in the substituted cos del, we used that e power ix plus e power minus ix. There both the argument was same. Here argument is not same, though, sir.
No, try to understand what is happening. If you make them equal, ठीक है, then phase difference will be constant. Not if you make equal, phase difference will be zero. If you make the phase difference constant, suppose k1 omega 1, k2 omega 2, they are equal, and plus delta is there. Even in that case, pattern is not at a particular point, intensity is not going to change.
Okay, sir.
No, actually, I'm just wait for 1 second. I will answer your question in a much better way so that it will be more clear to you. When we are solving this question where this was, so here. So actually we have this point P. What we find
Yes.
out? We find out this is the formula. ठीक है ना? At this point, this delta will be constant and this formula will be there.
Okay, sir.
ठीक है? Now, suppose this delta is not constant. Now, I'm saying that delta is equal to whatever formula, whatever they have written omega 1 minus omega t and like this. So it
Okay.
means that delta is going to change.
Okay, sir. Okay, sir.
It means intensity at this point is going to change. When you are going to change this delta, so what I can write here, I can write here that this E1 square, E1 naught square plus E2 naught square plus 2 times E1 0, E2 0. This cos delta, delta is a function of time now. What you're doing, your delta is a function of time. So your intensity will be a function of time. ठीक है?
Okay,
This
sir.
formula is valid. Now you are taking pattern. Pattern is continuously changing. When delta is changing, your pattern is continuously going to change on this screen. So what you do, you photograph this screen at a particular time t. So at this position at time t naught, what will be the situation? You are going to write intensity at point P at time t naught. This will be E1 naught square plus E2 naught square plus 2 times E1 naught, E2 naught. But now this cos delta at that time will have some particular value delta naught. By at time t naught, there will be some fixed frequency at a moment he is talking about. So corresponding to this fixed frequency at that moment, you can decide either you are getting maxima here, condition of maxima is satisfied here, or condition of minima is satisfied here, or some other. Suppose either condition of maxima and minima both are not satisfied, then here it will be neither maxima nor minima. So he's talking about at a point at a particular moment, because at a particular point at a particular moment, this delta will be fixed. This delta will be fixed. So we have to write the condition that at this point, what will be the condition of maxima? What will be the condition of minimum? One more thing I am going to tell you here. Just your question I have answered, but one more thing from your question I can ask. I can tell you. Just 1 second here. I'm writing here. Your formula is I equal to, this is E1 naught square plus E2 naught square plus 2 times E1 naught E2 naught cos delta. You are having this. This formula is valid for coherent sources. Coherent sources, we use this formula. ठीक है? What in that question he was asking? He was just asking for a moment. But I'm not talking about moment overall pattern. I'm saying for a long time, for a coherent source, this will be the intensity at a point. Can you tell me what will happen if your sources are incoherent in long time? That question was valid for a particular moment. that time it is okay. But if you are having incoherent sources as he has given, and you are talking about the average intensity at a point. So this was the intensity at point P on the screen. This was point P. Okay, if coherent sources are there, you are writing this is the formula. But my question is, if your sources S1 and S2, they are becoming incoherent, then in long term, what intensity here you are going to observe? Average intensity at this point. In long term, if your sources are incoherent, then what it will be? In that case, average intensity you want to find out. So try to understand these two are constant terms. This will be E naught square plus E2 naught square. So if you take the average values, they will come as it is, plus they are also constant E2 0. And this is variable. This will be cos delta. For one cycle, if you look at one cycle, this cos delta will be 0. Cos delta is 0. Average value of the cos delta is 0 for one complete cycle of the phase from 0 to 2 pi. Cos delta, average behavior of this cos delta will give you 0. So in this case, this will be 0 for one complete cycle. So average intensity in case of incoherent sources at any point will be equal to E1 0 square plus E2 0 square. Means it will be simply I1 plus I2. So if your sources are incoherent, then at every point, average intensity will be this one. ठीक है ना? This will be the average intensity. So that's why in your room, if you are having two bulbs, ठीक है ना? Then automatically light waves are emerging from these two bulbs and they are not coherent. And when they are not coherent, then on the walls and everywhere you are finding a constant pattern of a constant intensity you are observing on the walls and everywhere. The reason is this: if two sources are incoherent, their light waves are overlapping with each other, then time average of the intensity, average intensity, that will be simply I1 plus I2. So this is the intensity which we observe in our rooms when two or three light bulbs, ठीक है ना, they are providing light. ठीक है? So this is for incoherent sources. So for today, I am stopping here. In the next class, I will complete by this week. I will I will try to complete interference. In next three classes, I will try my best to complete interference in the best way. So, or I can take one more class if required, 3 or 4 classes. So you can save these slides. This is the first one, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12. So these are slides, different slides which I have discussed today. Okay,
Thank
beta.
Thank you,
Welcome
sir.
to welcome
Thank you,
to
sir.
welcome to good night.
Thank you, sir.
Welcome to